The 555 chips is one of the most popular chips in history. More of this chip have been made than just about any other chip. It's not really a logic chip, it's more complicated than that, but it's so useful I thought I'd tell you about it. It comes under a lot of names, but they all have a 555 in it to remind you which series it belongs to. It's an 8-pin chip, and this is its pinout shown here. You see that ground and VCC, the ground and power, are not in the usual places for a logic chip. And also, this is a chip that's very versatile about its power supply voltage. You can run it at 3 volts, you can run it at 5 volts, you can run it at 25 volts. You have to look in the data sheet to see the exact limits for whichever version of it you are using. It has an awful lot of uses. And if you understand this chip, you can make up your own. I'll show you just a couple and tell you how it works inside. So what this chip does is it has an output, which is a high current capable output. You can get up to, the output can be on the order of 200 milliamps, an order of magnitude larger than most of your logic chips. So you can drive significant loads just directly from this chip. That's a benefit in and of itself. But it's also got a really interesting behavior inside that allows you to use it as a comparator, as a latch, as a delay circuit, and in particular as a generator of square waves at whatever frequency you like. So let's talk about that particular use. First of all, how it works inside is that whenever inside it there is a voltage divider between ground and VCC consisting of 3 consecutive resistors. And that produces one voltage level which is 1/3 of the power supply voltage, and another voltage level which is 2/3 of the power supply voltage. And it's got comparators in there that compare the signal on the trigger to the 1/3 level and compare the voltage on the threshold to the 2/3 level. What it does is, if the trigger becomes less than 1/3 VCC, 1/3 of, say you're running it at 10 volts, 1/3 of, then it's whenever the trigger is less than 3.3 volts, the output goes high. And when the threshold pin gets greater than 2/3 of VCC, the output goes low. And with just those 2 features alone, you can build what's called a multi-vibrator, a square wave generator. Here's how that would work. I'll only draw parts of this chip as I start to draw a circuit diagram for it. We'll connect it up to VCC and to ground, and those could be not 5 volts, but 10 or whatever. I'm going to connect trigger and threshold to each other, and also to a capacitor to ground, and output, I'm going to connect that over to them as well. So let's pick an RC pair. I'll pick 1 microfarad and 1,000 ohms. And the product of those, you can see T, the product of those two, RC, is like a millisecond. So whatever this is going to do, we expect it to happen on a millisecond time scale. In fact, it's going to be that this will produce a square wave with about a kilohertz frequency. So why does that happen so easily? So you made a square wave generator out of an 8-pin chip and a timing capacitor and resistor, and that's it. That's pretty remarkably simple. What happens is, suppose that the voltage on this capacitor is initially 0 because you just put it there. So the voltage on trigger and threshold are also 0, and that means trigger is less than 1/3 of VCC, and so the output goes high. So the output goes high, and guess what? This capacitor starts to charge up. I'll draw the voltage on this right here, the voltage on the capacitor as a function of time. So it starts at 0, and it starts to go up because output is high. It's bringing current in here, and this capacitor is charging up. After a while, it gets to this level, which is 2/3 of VCC, 2/3 of the supply voltage. And at that point, threshold has exceeded the value 2/3 of VCC, and it brings the output low. When the output goes low, now this has got a voltage on it, about 6.6 volts. The voltage here is now 0, so this capacitor voltage starts to decrease again. Starts to ramp down. Nothing happens when that capacitor's voltage falls below 2/3 of VCC, but before very long, it also falls below 1/3 of VCC, and at that point, the trigger input is less than 1/3 of VCC, and the output goes high again. And so now the capacitor starts to charge up again. So it just alternates between those going up and going down. Meanwhile, if we looked at the output pin, the output was high up to this moment, and then it went low, and then it went high again at this moment, and then it went low. So we've got a series of a square wave sequence coming out whose timing is dictated by that capacitor and resistor. You can look online and find a vast number of different tricks and techniques and useful features that this one simple little chip can accomplish for you.